Okay, so if you didn't read the instructions on the sheet of paper, then I asked you to try number 27 and 28 on page 194, and then watch this video to see if you got the two of them right before you go on. So this video tells us this question tells us you flick a 5.5 gram coin up a smooth board propped at an angle of 25 degrees. This, of course, will be FG going down. So this is FGY. This is FGX. And this is going to be FN. Okay? And it's going this way. It's going up the incline. So this way it will be positive. If the initial velocity of the coin is 2.3 meters per second, so VI is 2.3 meters per second going up the incline, and the coefficient of friction between the coin and the board is 0.4. So mu is 0.4. How far does the coin travel before stopping? So VF is 0. And it wants the delta D. So to figure that out, we're going to need the A. Now you flick it up the ramp. And so by the time we've joined it, there's no forward force. You don't flick it and then keep pushing it. You flick it and now it's moving with some initial velocity. And because you don't keep pushing it, the VF is 0. So there's no force up the ramp. And because it's moving up the ramp, friction is down. So we start, of course, with the sum of the forces in the Y direction. Sorry, I was just looking to see my givens. And in the Y direction, it's not moving. So it'll be Fn minus Fgy will equal 0. So Fn will equal Fgy is the adjacent side. So Fg cos theta. And of course, Fg is mg. You could find this value, but don't do it. It is going to be nasty, right? Because 5.5 grams, you have to turn to kilograms and multiply by 9.81 and the cos of 25. Don't do it. Instead, go to the sum of the forces in the x direction is equal to max. And the only forces in the x direction are Fgx and friction. And they are both going down the incline, which means they're both negative because the coin is going up the incline. So there's no force acting in the positive direction. That's why it eventually stops. So Fgx will be Fg sine theta, and FFR will be mu Fn equal to max. Fg is really just mg sine theta minus mu, and Fn is really mg cos theta is equal to max. Cancel out the m's because it's in every term. Solve for ax. So negative 9.81 meters per second squared. Sine of, I think it was 25. Yeah. Sine of 25 minus I know it told me 0.4 times 9.81 meters per second squared times the cos of 25. You should definitely get a negative number here. And I think it's negative 7.70 meters per second squared. Okay? And once you have that, now you can come back over here and say, well, VF squared is equal to VI squared plus 2A delta D. The VI goes to 0. So delta D will be equal to negative VI squared over 2A. So negative bracket 2.3 meters per second squared over 2 times negative 7.7 meters per second squared. And when you do this, you get a delta D of 0.343 meters, I believe. Okay? All right, and number 28. So, inclined plane. You're pushing a 53 kilogram crate. So here's my crate, 53 kilograms. And you're pushing it up the incline, so this is going to be F. You're pushing 50 at a constant velocity. That means AX is going to be 0. While I'm here, this will be FG FGY, FGX, FN. Now let's see what else it says. The ramp makes an angle of 22 degrees with the horizontal. So this is 22 degrees. And the force you're pushing with is 373 newtons. What is the coefficient of friction? You're pushing it up, so friction must be acting down. Mu equals question mark. All right, start with the sum of the forces in the y equal to MAY. Of course, it's not moving in the y, so it'll be Fn minus FGY equals 0. So Fn equals Fg, that is the adjacent side, cos theta. So Fn equals mg cos theta. Okay, you could find the value, but I'd probably wait so I wouldn't have to end up rounding, and I would go to sum of the forces in the x direction. This time in the x direction, there's a force going up that you're pushing with and 2 going down. So it'll be F minus FGX minus friction equals MAX. So it'll be FGX is really mg sine theta, and friction is really mu Fn, or mu mg cos theta, is equal to MAX. And you're trying to solve for mu, so bring this term over and bring this term over. So it'll be F minus mg sine theta minus MAX equals mu mg cos theta. Notice this time the m's do not cancel out because there's no m in that F. So you cannot cancel the m's out. So you need to divide by mg cos theta. So you'll have mu equals F minus mg cos theta. Oops, sorry, just switched it. Minus mg sine theta minus MAX is going to equal, is divided by mg cos theta. And now fill your numbers in. So it was 373 newtons minus, was it 53? Yeah, minus 53 kilograms times 9.81 meters per second squared. And this again is a sine of 22 minus 53 kilograms. Oh shoot, it said constant speed, didn't it? It did. So this MAX goes to 0. We wasted all that ink for nothing. Divided by 53 kilograms times 9.81 meters per second squared times the cos of 22. Plug it into your calculator, and when you do, you should get 0.37. I only kept 2 decimals, so I don't know if that means it's really only 2, or if I rounded an awful lot. 3.373 minus 53 times 9.81 times 22 sine divided by brackets 53 times 9.81 times 22 cos. Oh, mu is equal to 0.3697. Okay, so now I'd like you to do some more on this sheet that I gave you in class. This guy, try numbers 1 to 5. 5 is the only one that should really perhaps screw you up. And we are going to do this lab that I gave you as well. I don't know if it'll be tomorrow or if it'll be the next day. It kind of depends on how you're getting along with the questions before I toss a lab in on you. So we'll see. If we do it tomorrow, it'll be the second half of class. So maybe just look it over, or maybe we'll leave it for the following class day, okay? But it's coming soon to a classroom near you.